Now, a real world example of game theory occurs when two people are caught when they're involved in a bank robbery. Okay. And if you're curious about where this is headed, this has to do with oligopoly, I promise you. Okay. But let's just start with this interesting game. So, two bank robbers are caught. And the question is, what should they do when questioned by the police? Um, this game is famous and it's become known as the prisoner's dilemma. Okay, so it's this famous strategic game in which two prisoners have a choice. They have two strategies that they can choose between. They can either confess to their crime or they can basically not confess. They can stay quiet. Now, there's different outcomes depending on the combinations of choices they make. So if neither one confesses, if neither bank robber confesses, they both serve a minimum sentence. On the other hand, if both of them confess, they serve a longer sentence. And then there's sort of this intermediate ground where if one confesses and the other doesn't, the one who confesses goes free, while the one that doesn't confess gets a really, really harsh penalty. And as it turns out, there's a dominant strategy in this game, and that dominant strategy is to always confess, regardless of what you think the other prisoner does. Okay? And this is why it's called the prisoner's dilemma. And recall that when they both confess, they serve a longer sentence. They could serve a shorter sentence if they both did not confess, right? So again, here's the summary of combinations of strategies and the outcomes. So again, the two are interrogated separately, and their interrogator indicates the following, right? He tells them this is what's going to happen. And so this is actually a strategy commonly used in law enforcement when there are partnerships in crime, right? They catch the partners in crime and they immediately separate them and question them separately. And usually there's the good cop, bad cop thing going on as well. But they basically use this strategy to try to get them to confess because law enforcement for a very long time has realized that there is, in fact, a dominant strategy in confessing. So again, if both confess, they each get 5 years in jail. If neither confess, they get 2 years, right, based on a lesser charge. So this seems like the better outcome, right? Only 2 years as opposed to 5 years. But then there's this interesting caveat where if one confesses, the person that confesses goes free, but the other person that doesn't confess gets 10 years, right, which is the worst outcome. All right. So this aspect right here is actually what ends up making confessing a dominant strategy. So what would you do if you were in this situation, right? Keeping in mind that there's no possibility for cooperation. The two players can't talk to one another. They can't coordinate in any way. They just know that they've been caught, they've been separated, and that these are their options, right? So what would you do? Just for fun, as an easy last discussion post, why don't you tell me in your discussion for your discussion post what you would do and why? Now, an easy way to illustrate this game is in a payoff matrix, which we'll see in a second. But basically, there's 4 possibilities. Both confess, neither confess, prisoner 1 confesses while prisoner 2 doesn't, and then vice versa. And so if we can put this in a matrix, and it sort of helps us analyze the game. So we've got 2 players, Carol and Sam, the bank robbers. And then each of them has their 2 strategies. So Sam can either confess or not confess, and Carol has the same 2 strategies. And then in the intersection of the 2 strategies, we see the payoffs. So here we have confess and confess. That's this box here. And then we see the 2 players' payoffs. Sam gets 5 years in this case, and Carol also gets 5 years. And then we see it for the other combinations of strategies as well. So in this case over here, we have Sam doesn't confess while Carol does confess. And since she confesses and Sam doesn't, she gets to go free while Sam gets 10 years. It's the opposite case for when Sam confesses and Carol doesn't. And then here's the outcome here where they both do not confess and each of them get the smallest, well, other than going free, the sort of better outcome where they only get 2 years apiece. So, right, this is, if they could somehow coordinate and cooperate, this is kind of where they want to be, right? Yeah, they both have to go to jail, but it's the least amount of time where, other than this case, but in this case, right, one goes free and the other one spends a long time in jail. So, right, this kind of is good for one person, but not for the other. So, if they were able to coordinate with one another, this is kind of where they'd want to end up, right? But the police are using to their advantage the fact that there's a dominant strategy here. So think about this, right? Suppose Carol really strongly believes that Sam is not going to confess. What's her best choice, right? We're in this column because she's assuming Sam doesn't confess. What's her best choice? Well, what are the two outcomes? Go free or 2 years in prison? What's better? Well, going free, right? And that means that she should confess. What if, on the other hand, she assumes that Sam's going to confess and we're in this column? Well, what's her best outcome in that case? 5 years in prison is better than 10 years. And so, again, she should still confess. And so here you should be seeing that this is the dominant strategy. It doesn't matter what Sam does. In both cases, it's best for Carol to confess. And as it turns out, it's the same for Sam, right? Now let's suppose Sam assumes Carol will confess, and so we're in this row here. What's his best choice? Confess or don't confess? Well, clearly Sam should confess if Carol confesses. What if Carol doesn't confess? And we're down here in this row. What's better for Sam, 2 years or going free? Going free, right? So again, he should confess. So Sam also has a dominant strategy in confessing. So no matter what Carol does, Sam should confess. No matter what Sam does, Carol should confess. So they both end up confessing to the crime and they each get 5 years in prison. Right? So again, regardless of what the other prisoner does, both people are better off by confessing. Confessing is the dominant strategy, and so each of them end up behind bars for 5 years. All right, so the reason we look at the prisoner's dilemma is because this turns out to be the exact situation that oligopolies face, albeit usually not with regard to some crime and confessing or not confessing, but rather a choice of high price or low price, right? So applying game theory to pricing strategies would be a way for us to look at oligopoly behavior, and it turns out that oligopolies face a prisoner's dilemma as well, right? So think about this. There's two oligopolies, and their choices are charge a high price or charge a low price. And for now, we're assuming that there's no collusion, right? There's no opportunity for coordination or cooperation. All right, so we've got our game matrix. We've got firm 1 and its decision to charge a high price or a low price. We've got firm 2 and its choice to charge a low price or a high price. And then the different outcomes in terms of their profit or revenue. Doesn't really matter. We'll just assume profit, okay? Okay, so let's see here. Let's just start off with firm 1, right? It's trying to make its choice. And it starts off by assuming firm 2 charges a low price. Well, if firm 2 charges a low price, what is the best response for firm 1? Well, 4 million in profit's better than 2 million, so it should choose low price if firm 2 charges low price. What if firm 2 charges a high price rather than a low price? Well, what's better for firm 1, 6 million or 8 million? Clearly $8 million in profit's better, and that also goes with the choice of low. So in that case, here, again, we see a dominant strategy. It's always best for firm 1 to choose a low price. And if you did the same thing, maybe practice this on your own, pause the video and practice this for yourself and prove to yourself that firm 2 also has a dominant strategy in choosing a low price. And so they will both choose a low price. They will both earn $4 million, even though if they could somehow coordinate, they could both earn $6 million by charging a high price. Okay? So again, same thing. It's a prisoner's dilemma. Now, these types of situations give a rise to opportunities for opportunistic behavior. So opportunistic behavior is this sort of scenario. It consists of actions that, because of long-run benefits of cooperation, are perceived to be smaller, and there's a focus on short-run gains. So an example of this might be writing a check that you know will bounce. Yeah, you can write the check, right? Maybe you're buying a car, right? And you write the check, the seller takes your check, you drive off with the car, and your check bounces, right? So in a sense, there's a short-term gain. You get a car that you didn't pay for, but it will lead to a long-run loss for you, right? Either because maybe the seller will somehow track you down and hurt you or sue you, or take some other course of action to hurt you. But even if that doesn't happen, if you write a bounced check, there's going to be a loss of trust in your ability to make payments on things in the future, especially if you do it repeatedly. And so basically, the implication is a non-cooperative game, which isn't realistic, right? This short-term gain in a sort of one-off scenario where you just play the game once isn't realistic, because in real life, we make repetitive transactions, right? We do things repetitively. And so that provides an opportunity for us to gain a reputation for ourselves. So although there are opportunities for opportunistic behavior in these sort of one-shot games, such as this, if these firms repeat these decisions over and over again throughout time, they can develop reputations. And so there's actually maybe an opportunity for them to get here if they can develop these reputations and play this game repeatedly. And so when these games are repeated, when they are played repeatedly, there's an opportunity for something called a tit-for-tat strategy. And so this is a game theory strategy in which there's cooperation that continues as long as the other players continue to cooperate. So you may have even engaged in tit-for-tat strategy yourself, where it's like, yeah, I'll let you borrow my video game if you let me borrow mine. I'm sorry, if you let me borrow one of yours, and then we return it at some point, right? Maybe you've had this situation with a friend, or maybe not video games, but something similar, maybe clothing. And you continue to do that, right? Trade clothing with one another as long as you're trading back and forth. But as soon as you let your friend borrow a game and they don't let you borrow one of theirs, you stop lending them your games, right? You stop cooperating with them. So maybe you've engaged in tit-for-tat strategy before, but that's basically what it is.